Hello, today let's try to solve some Leetcode problems. Now let's first go to Leetcode 58, the length of last word. So we can directly use the Python library. We can just return the length of the string dot split. So this split is just to remove the padding zeros, just to remove the prefix zeros and the suffix empty string, the prefix empty string and suffix empty string. So this is split, and also in between all the empty strings. After split, we can just get the last word. So actually this is the entire code, just one line. Now let's move on to the second +1. So for this one, I'm also gonna use some a library in Python to solve the problem. Now let's try to solve this one. Leetcode 66 +1. So we are just giving digits array. We need 2 + 1, and the result return would also be an array, but it would be +1 at the end. Now I just need to turn this digits into an integer first, so I can gonna use empty string dot join array. So inside it gonna be string, so string I for I in digits. Now this number is actually a string. I want to turn this number into an integer, so I can use int n. And finally, I need 2 + 1. Now I just need to return the result. So the result would be integer. Yeah. So it will be int I for I in string n, because here we also need to turn this number into a string. And then we take out each of the string and turn this string to an integer, and this is actually the result. Now let me submit it to check. And the time complexity is just O(n). Yeah, this is just for increase the speed and to avoid any mistakes. Yeah, you can also use the carry method. You don't need to turn this into string and integer. You can just calculate it directly. You can use a carry to check this number and then check this number and check the first number and then return the result. But that will be more lines of code. Now let's go to the next one, add binary. So for this question, add binary, I still gonna use the library to solve it. Yeah, because it's gonna be save time. Yeah. So for this one, we just need to turn the final result. Let me return this final result. So it's gonna be, we can use a binary bin of this. Yeah, I don't need to use. Let me use integer first. I need to turn this string into an integer, but it's gonna be a binary integer. And I need to end the b similarly. And finally, I just need to return a string. Yeah, so I can put it inside a bin, because for the bin, it is actually a string. So we need to remove the first two strings. Yeah, because those first two strings is basically 0x. We need to return that first two strings. Now let me just run it. There's some problem. Yeah, I didn't remove it. I needed to remove it from here. Yeah, This means I remove the first two. It is not 0x, it is a 0b because it's a binary string, 0b. Oh, still something wrong. Oh, I did something wrong. I don't know why every time I make it with a colon. It's not colon. This is yeah, it should be 2. It should be starting from the index 2. And this 2 dots actually means the slice. Yeah, let me just try again. Yeah, let me refresh and try again. Yeah, it seems there's a host error. I might go to the English version Leetcode to try to check this one. Now let me run it to check something wrong still. Yeah, because I didn't update it yet. Now let me run it. Now it seems okay. Now let me submit it. Yeah, I will move on to the next problem. So next one would be square root of x. So for this one, we cannot use a library because according to the description, it is said, we cannot use the library. We have to use a binary search to solve this problem. So let me prepare two variables. L and R would be starting from 0 to x. Because we cannot use the library, so we're going to use a binary search to solve it. So while L less than and equal to R, M should equal to L plus R minus L divided by 2. So if M times M more than the target, so this means R should be, this means the midpoint is this number M is too large, so it will become smaller, M minus 1. So if M times M less than the target, so this means it is too small, so the left pointer would be equal to M plus 1. So else we can return this M. Otherwise, what we're gonna return is just L minus 1. Because for this binary search template, I would always return from the left side, but here we need to round it. Because according to the description, we need to round it down. If we need to round it down, this L is too large. So for example, this L is 3 at the moment, midpoint plus 1. We need to round it down to L minus 1. So if it is just an integer, for example, the result is 2, we can return it directly. Otherwise, we have to minus 1. So this situation means we didn't find, but we needed to round it down. Now let me submit it. The target is not defined. Oh, it's not target, it is X. As you can see, it works. Now let me submit it. As you can see, it passed. Now let's continue to solve the next one, climbing stairs. So for this one, climbing stairs, it is just like Fibonacci numbers. What I need to do is just finish writing the Fibonacci number template. So I'm gonna prepare a first and a second. The first means if n equal to 1, so there is only one way. If second means if I need to step to the step 2, I need to go to, if there are 2 steps, I can choose 2 ways. I can jump directly 2 steps, or I can jump 1 step and 1 step. So there are 2 ways. So this means the second is there are 2 steps. Now I can check others. So for I in range from 3 to n minus 1, I can check n steps. So the second and first would be just updated to first plus second, and the first would be the second. Finally, I just need to return the second if second more than or equal to 2, else just need to return the first. Now let me submit it. Let me check. So if n equals 1, I get a 2. Second more than or equal to 2. Else I need to return a 1. Let me try this. Oh, this is a strange. Yeah, if n equals to 1, I return the first. It means the first should always be 1. I don't know why the first becomes 2. This is really strange. Yeah, because the first is always 1. Here is this n, I didn't execute actually. Yeah, because this n is only 1. So if second is more than or equal to 2, I'm gonna return this second. The second is 2. Yeah, because this n is 1, I think I returned the first, but actually didn't work. Yeah, I think here I should use n should be, yeah, I cannot use the second because this second equal to 2. The second always works, so I need to change it to n because finally I check the value of n, it's not the second, so this is why. Yeah, as you can see, it works. Yeah, because any typo or any logic error can make mistakes. Now let's go to the next one. Remove duplicates from sorted list. So this is gonna be, yeah, in a sorted list, there are duplicate numbers. We just need to remove the duplicate numbers. For example, this is a 1, 1. We just need to remove this one. And let's use this example. So we're gonna remove this one, and this is 3. Yeah. So I'm gonna prepare a p pointer would equal to the head. And now I'm going to check the p pointer while p and p dot next. I'm gonna check if p dot value equal to p dot next dot value. Yeah, if the two neighboring nodes have the same value, it means I need to jump. So p dot next should be equal to p dot next dot next. So else, so this means the p dot this means I need to shift the p because they are not equal. I'm safe. I just need to shift the p to p dot next. So if they are equal, so the p dot next should equal to this one would be connected to 2. And next, they are not equal, so this means p will move to this node 2. And then I'm gonna check it's not equal, this p pointer would be moved to 3. And then I'm gonna check if they're equal, so this 3 node would be pointed to its next, pointed to none. So finally, I just need to return the head. Now let me submit it. Some typo error still. Yeah, because here I need to check if they're equal or not. Yeah, as you can see, it works. Now let's move on to the next one, merge sorted array. So for this problem, we are giving two sorted arrays actually. This is nums1 and nums2. Both of them are sorted. We need to return nums1. Actually, we don't need to return anything. Just modify nums1 in place. Yeah, because for these three areas, there's nothing. Just keep it at 0. We just need to put the numbers inside nums1. Yeah. So the best way to solve this problem would be 2 pointers. So I'm gonna prepare, actually it's 3 pointers. I'm gonna prepare 3 pointers. So for the I, it is for nums1, it will be n minus 1, and z is for nums2, it will be n minus 1. And this k is for the position from the right side of nums1 until to the left side. I need to fill in all the numbers and also keep it in increasing order. So this k would be m plus n minus 1. Now I need to check this z. So while z more than and equal to 0, yeah, so this is why, because I just need to check the numbers in nums2. If there's still numbers, I'm gonna insert it into nums1. Yeah, so let me do a check first, because for this I, it has to be more than or equal to 0 if I were to put the values in nums1. For example, this is 3, put it at some other positions. I have to check if this I is more than 0, and still nums1 I is more than and equal to nums2 z. So if it is like this, so nums1 k should be equal to nums1 I, and k should be minus 1. So else, if it is not the case, if I less than 0 or nums1 I is less than nums2 z, it means nums1 k should be equal to nums2 z, because nums2 z is bigger. Now, finally, I just need to let me check. So yeah, finally I need to k minus 1, but here actually it's not k minus 1. Here should be I minus 1. Yeah, because if I put this I inside, I'm gonna check the next number in nums1. It's gonna be after 3, it's gonna be shifted to 2. Yeah, so this means all the numbers would be checked from the right to the left side. Because it is in place, I don't need to return anything. Now let me just run it. There's some mistakes. Index out of range. If this I more than 0 and nums1 I more than equal to nums2 z, it means nums1 k should be equal to let me use more. If this nums I more than, not equal. Oh, it's still yeah, I think there's still some error. So for here, while I get this z, I need to -1. Otherwise, it's gonna never stop. Yeah, because here I get a value of z, so z should -1, and here I get a value of I should -1, and finally this k should -1. Yeah, now it works. So yeah, it's just because I didn't update this z. Now let me submit it to tag. Yeah, it seems works. Now let's just go to the next binary tree in order traversal. So for this problem, I'm gonna use a stack. Yeah, because for DFS, pre-order traversal for the recursive solution, we solved it many times, but this way, I think it's better to practice the stack, the iterative solution to solve this problem. So for the stack, basically, we just need to initialize a empty stack for this problem, and also a result would be empty array. Now I need to check if there is a stack, if there is something inside of the stack, or the root is not known. So I can still use a while loop to check if while root, I need to put the left side inside of the stack because this is in order traversal. So the stack should append this root, and then the root will be go to root.left. After finishing the left side, now I can go to the root. So the node would be stack.pop. Actually, this is the root. So the result can take a value, so append not.value, and after that it will go to the right side. Yeah, because I finished the left side, and then I go to the root. After finishing this root, I go to the right side. So root should equal to the not.right. So this is the entire code actually. So for this example, we just needed to check the left, there's nothing, and then we go to this root and we take the value. Now, after take this value, we go to the right side. Yeah, after we go to the right side, we still go to the left side. We put 2 inside the stack and then put 3 inside the stack. Now we're gonna pop out 3 first, and there's no right, no right bronze. We will go to this 2. Yeah, we will take the 2 inside the result, and there's no right node. We can just get the final result. Still something wrong. Let me check. Because I didn't return anything. I need to return the result. Now let me submit it. Yeah, as you can see, it works. Now let's go to the next one. Next one would be the scene tree. It's gonna still be a tree problem. So for this problem, actually, I want to just use the recursive way to solve it because it is much easier. We don't need to use other ways. Yeah, let's just write the recursive function. So for example, for this one, we just need to check what is true and what is false. If not P and not Q, we can return true. Yeah, because there's nothing. It means we find the leaves. There's nothing. Else we're gonna check if P and not Q or Q and not P or P dot value not equal to Q dot value. This means we can return a false. Otherwise, we go to the recursive call. Yeah, we just go to the recursive call to P dot left. and q dot left, and we go to the self dot, go to the p dot right and q dot right. So this is the entire code. Let me just run it. Yeah, maybe I can just copy the code and try to run it from here. Yeah, it is stuck. Let me search this problem. Yeah, it's gonna still be an error to fetch the result. Yeah. Yeah, no, it works. Let me just submit it. Yeah, so there's a problem. Non-type has no attribute val. Oh, this is a string. Yeah, because this p can be empty, as you can see from here. So this p can become empty. Well, p and not q, or q and not p. Yeah, so here I got a typo. I think this can avoid that mistakes. Now let me just submit again. Yeah, as you can see, it works. Now let's just go to the last question. So for this one, it's gonna be symmetric tree. Yeah, it's gonna be exactly the same, I think. Yeah, so these areas would be very similar to these problems, while we are using the recursive solution to solve it. Yeah, now let me just write a function. So I'm gonna use so here is a symmetric. I'm gonna use a symmetric to finish it. So for the symmetric, I'm gonna still use p and q. So I'm gonna copy these areas. Yeah. So this P and Q means it's just two node, two root. This is for the left root, and this Q is for the right root. So if not P and not Q, I can return a true. If this is P and not Q, or Q and not P, or the values are not equal, I can return a false. So finally, I just need to copy the symmetric from this area. So it would be here, P dot left would be compared with Q dot right. Yeah, because this is not the same, and Q, it is symmetric, and P dot right should be compared with Q dot left. So this is for the symmetric function. Now, finally, I just need to return this is symmetric with root dot left and root dot right. Yeah, because we have at least one node. This means we don't need to check this root because we have this root, and then we're gonna go to check this left and right. And for this left and right, we just use this symmetric function to check it. Yeah, if we go to the leaves, we don't have P and Q, we're gonna return true. Otherwise, if we have P not Q, or if we have Q not have P, or the value just not equal, we just need to return a false. Otherwise, we're gonna recursively check this left with right, with P dot right with Q dot left. Now let me submit it. Yeah, as you can see, it works. Now let me just submit all the testing cases. Yeah, it seems works. Thank you for watching. This is for today. See you next time.